2012 16th question, it says, show that the center of mass of a solid right circular cone. Show that the center of mass of a right uniform solid right circular cone. Height h is at a distance 1/4 from the base of the cone. Right. So once again, they have asked you to find the center of gravity of a cone from the base of the cone. Right? From the base of the cone. So like once again, it's going to be integration question. Like it's pretty straightforward. It's pretty straightforward because we have done and we have found the center of gravity from the vertex though. Right? So same thing, right? Same thing. Right. Okay. Yes, I think you can do it on your own. The integration part, right? So I'm not going to prove that because like, we have already done those things in the note, right? So therefore, let us move on to the question though, right? Okay, so let's see. A uniform solid composite body consists of a right circular cone of base radius 3r and height h and a right circular cylinder of radius r and height 2h fixed together as shown in the figure. Show that the center of the mass of composite body is on its axis of symmetry at a distance of from the vertex of the cone, right? So vertex of the cone cone vertex center of gravity of the composite object in the x and y axis, we need to place the composite object such that the vertex of the cone coincides with the center. This is 2012 16th question. So it's like this. Right? There's a cylinder, right? I have told you, although this is given in somewhat 3D shape, you will have to plot the 2D figure. That will be easy for you, right? Okay, so this is the figure that is being given, right? So let's mark the data. A uniform solid composite body of right circular cone of base radius 3r. So base radius of this cone is what? Base radius is 3r. Base radius is 3r. Right? Base radius is 3r. And height h cone and right circular cylinder of radius r and height 2h So the radius is of this radius is r, height is what? 2h. Height is 2h. Right. Okay. So now what they are asking is show that the center of the mass of the composite body is on its axis of symmetry. Show that the center of the mass of the composite body is on its axis of symmetry at a distance of 5/4h from the vertex of the cone. Right? So the vertex is 5/h දුරකින් තමයි මේකේ center of gravity තියෙන්නේ කියලා පෙන්නන්න කියන්නේ. Right? So like yes, let's do that. Right? Fine. First of all, like we'll have to plot the table. Right? Yes. Let's do that. Let's take less space though this time, right? Object, mass, and COG from origin. Center of gravity from origin. What is the object? First object, the cone. The cone, mass of the cone, how do we write? Density into volume. So volume of the solid cone, how do we write volume of solid cone? 1/3 pi r squared h. 1/3 pi r squared h. Right? 1/3 pi r is what? 3r. So 3r squared h is what? H is simple h. So what will be the answer here? 3 squared is 9. 9 divided by 3. 9 to 3 cancels 3. So 3 rho 5 r squared h. Answer is 3 rho 5 r squared h. What is the distance from the center of? So what is the distance to the center of gravity of the cone? From the vertex? They have given in the, like you will have to always look at the upper part that you proved. So you were supposed to prove what? The center of gravity of the cone. The center of gravity of the cone is at where? From the base 1/h. From the base h over 4. From the base h over 4. So from vertex 3h over 4. From the base h over 4 means from the vertex 3h over 4. Right? Now, so from origin it should be 3h over 4. 3h over 4. Right, let's go for the cylinder. Right? The density rho, volume is 5 r, radius is r, 5r squared, h is 2h. So the center is where? Center is here. So this is 2h. So the center of gravity is at where? Is at h. This is 2h at. Is it correct? This is 2h. So the center of gravity of the cylinder is at h. This is wrong, right? So the center of gravity from origin. This is h. So from origin it is 2h. Should be 2h. Now let's go for the composite figure. right? So let's add the two. 2 5r squared h, 3 5r squared h. When it is added, 5r squared rho h. When these two are added, it's going to be 5r squared rho h. Okay, this is 2 5r squared rho h. This is 3 5r squared rho h. So therefore, we added 5r squared rho h. So the center of gravity is, I don't know, maybe somewhere here. X bar, right? So we do not know that exactly where it's, right? We need to find this. This is the goal, right? To find this. So what do? We have to, yes. So this and this, these two objects joins to form this. These two objects joins to form this. Therefore, this and this joins to form this. So that, which means this product plus this product gives us this product. This product plus this product gives us this product, right? Yes. So I'll use this space straight in it. This product. 3 rho 5 r squared h into 3h over 4 plus this product plus this product 5 r squared 2h into 2h. This product is equal to what? Equal to this product. 5 r squared rho h x bar. So rho to rho cancels. 5 to 5 to 5 cancels. R squared to R squared cancels. 1 H2 H cancels. So what remains is 3 into 3 9 9H over 4 9H over 4 plus 2 into 2 4H divided by 5 x bar. So let's get the simplify this thing what we call the simplification, right? 9H over 4 plus 4H 5x bar. So 9H plus 16H over 4 is equal to 5x bar. So this is 25H. So this is 20 x bar. When you divide x bar by up and down by 5, it will be 5H over 4. 5H over 4. So the answer is okay. So that is what they have asked. Sorry. That's what they have asked, right? Center of mass of composite body. 5H over 4. Let us see the next part, that is the composite body is hanged freely. The composite body is hanged freely in a vertical plane by light inextensible string, one end of which is fixed to ceiling and the other end to a point A on the circumference of the circle of the base of the cone. The composite body is hanged freely is hanged freely in a vertical plane by right index and string, one end of which is fixed to the ceiling and other end to point A. Right? It's like this. Five h over 4 means center of gravity somewhere here, right? 5h over 4. Center of gravity somewhere here. It's hanged on a ceiling. So it will look like this. See the weight. It's hanged from somewhere here, A. A. So why did I straight away draw it as this? So that you can think about this. Can it be in this way? Can they hang it as this? No, because why? Center of gravity is here. Always it should be in the vertical line. Always it should be in this way. Like which means it should turn. It should be in this way. This is the vertical line it was hanged with, right? So this should also come into that vertical line. Right. So if it is hanged, obviously you know there's going to be about tension. Tension. What else are the forces? Only tension and W, right? So because there's no contact surfaces and all, right? It's going to be easy. Yes. And then they're saying if the axis of the symmetry of the composite body, if the axis of the symmetry of the composite body makes an angle with downward vertical alpha. This is the axis of symmetry. If this makes an angle, so what is the downward vertical? This is the downward vertical. If this axis of symmetry makes an angle alpha, so this is alpha, right? That is alpha. This is alpha. Right. So makes an angle alpha. Show that tan alpha is 12 ROH. 12 ROH. It's very easy. This is alpha. This is also alpha. So what is this length? That is 3R. 3R. So what is this length? Actually, what is this length? What is that? That is x bar minus h, right? This is x bar. This is h. This is h. So this is x bar. This is h. So this is x bar minus h. So from here, this is x bar. This is h. So from x bar, if you subtract h, you are going to get this way. I guess it's clear. So that you can write what? Tan alpha is equal to what? So consider this triangle. Consider this triangle. Tan alpha opposite is 3R. Opposite is 3R. Adjacent is what? X bar minus h. X bar minus h. X bar minus h. Right? So, yes, let's simplify that. Right? So, tan alpha 3r. X bar is what? 5h over 4 minus h. Tan alpha 3r. 5h minus h is h over 4. Right? Tan alpha is 4 goes up 12r OH. 12r OH. Which means they are asking tan alpha. Yes, tan alpha is 12r OH. Right. That is done. That part is also done. And then they are still asking. So was this by applying along the x-axis of symmetry of the compass by applying a force P, by applying along the x-axis of the symmetry of the composite body a force P at the vertex, the composite body is kept in equilibrium so that the axis of the symmetry of the composite body is horizontal. Find the force P. Find the force P. It's like this force here by on the vertex. By applying a force P, you can keep this vertical horizontal. This axis horizontal. Saying by applying an appropriate horizontal force capital P, a force P, by applying horizontal force P, you can make this remaining horizontal. Right? So what are we going to do? Yes, by applying P, so they are asking us to find the P. Find the P. This P point, the P force. What is the required P force to keep this in equilibrium? So when this is in equilibrium, what happens? So this is the tension. So the weight is here. They have assumed allowed us to take the weight as W. Right? Okay. So fine. By applying this, you can keep it vertical. So this is the point A. You need to find P in terms of W. How would you do that? How would you do that? Right? So yes, around A, I will take a moment. If this is in equilibrium, the moment around A in the anti-clockwise direction should be equal to the moment around A in the clockwise direction. Simply applying a moment, right? So, like, if an object is in equilibrium, the moment of the A. So, like, if the object is in equilibrium, the moment of the object in the clockwise direction should be equal to the anti-clockwise direction. Moment in the anti-clockwise. Moment in the clockwise should be equal to moment in the anti-clockwise. Right. So, yes. Fine. Yes. P, what is the moment around A in the clockwise direction? P into what is this? P into 3R. P into 3R. P into the perpendicular distance is 3R. Perpendicular distance is 3R. P 3R. That is equal to what? So what is this? So around W, this is the perpendicular force. So this goes down. What is this distance? W into what is this distance? From XY you need to subtract H. From 5H you need to subtract H, which means it is H over 4. H over 4. This H over 4. This is H over 4. From 5H you need to subtract H. It's H over 4. So P is what then? W equal H 12R. 12R. P is equal to W. I'll take 12R H down. What is this? 12R of H is tan alpha. That is tan alpha. So W over tan alpha. P is W over tan alpha. They have asked P in terms of W and alpha. In terms of W and alpha. Right? And then also they are asking the tension. They are asking the tension. When you need the tension, where will you apply the moment? You will apply the moment to the vertex. When you need P in terms of W, you don't want T. So therefore you apply the moment at where? At A. So when you need the moment, when you need the force tension, you're going to apply the moment here. Then this will not come into the equation. Right? So vertex, I consider this as O at O. At O. T, what is this? T into H. T into perpendicular height is H. W into 5H over 4. W into 5H over 4. This to this cancels. So T is equal to W of T is equal to W of. So how many marks? 150 marks. Right? So this question is not worth of 150 marks because I think is the yes, there was nothing